Hello everyone, this is Flavio Villanustre with HPCC Systems, and we are in our 5 questions with series. Today we have Anthony Fishbeck. And for those, and I don't think there are that many out there that don't know Anthony, he's been a senior architect and involved in HPCC Systems for a very, very long time, possibly far longer than many other people in the initiative, in the project. He's, of course, an expert in distributed large-scale data technologies, and he's been doing this for a very, very long time, as I said before. He has a number of interests on his side, including adaptive and componentized platforms, and certainly all that has to do with the implementation of open standards for communication and, of course, security as well. He is the person behind the ESP platform. The ESP platform, the ESP name doesn't have Tony anywhere, even though he was the one creating it and driving the standards and architecting it from the ground up, and has been doing that all along for 18 years, which is really a very long time. Of course, ESP today doesn't look anywhere like it was when it started, and it's one of the areas where HP Systems is changing rapidly to adapt to new standards and new requirements in the modern world. So, welcome, Tony, and thank you very much for doing this. This is, as I said before, 5 questions and maybe one or more additional questions, perhaps. And we want to listen from you. So, hello and welcome.
Thank you, Flavio. It's great to be here.
So tell me a little bit about the original design criteria for ESP. How did ESP come to be? Why ESP?
Yeah, so actually, so 18 years ago, 2001 is when I started at the company, and ESP itself started as a project to create a farm of distributed image servers that would serve up a massive number of JPEG images for a project we were working on. And but at the time, it was a very dynamic environment, very startup-oriented. So I never knew what was going to be happening next. And so I really wanted to create a platform that I could continue to develop and grow as new projects came up. So my main focus was really just that, yes, it had to be very fast and high performance, but I wanted something that was very flexible and adaptable over time. And so that was my main focus. And in fact, over time, ESP sort of become known for that. For example, when we acquired another company and wanted to integrate our technology with their existing systems, it was, they had their own proprietary protocols, their own back-end systems. It was the ESP, because of its flexibility and adaptability, that we used to plug all the HPCC technology into that existing environment without changing any of the other components very much. So
that is very interesting. That's like a trivia question. Very interesting that it started really to serve those JPEG files in a high-performance environment, and eventually became this presentation layer plus for HPCC Systems as a platform. But wait, now it's I need to do this. Every time I talk about HPC Systems and people learn that HPC Systems uses ECL, they always ask the question, why ECL? Why didn't you just use language XYZ? Regardless if it existed or not at the time, we decided to go with ECL. And I need to ask you the same question. So why a new platform to deliver JPEG files? Why not Apache or the web server of the time? I don't know, NCSA server or whatever it was.
Yeah, so a few things. First of all, the ESP is built on the same libraries as the HPCC systems. So the idea was that we could start to integrate it very closely with the technology on the HPCC. For instance, now the ECL Watch is really just a set of ESP services. And it's built on all those same libraries that allow it to just very tightly access and integrate with all the stuff that's going on in the HPCC. Also, the original protocols were not, ES2 was not originally built as a web services platform. It's built as a very modular, dynamic, flexible platform. So the original protocols were not like HTTP and other things that you'll find on standard servers. And using that example from before again, when we had plugged in to the existing system of that other company that we acquired, those were not standard protocols. Those were other protocols. So it's really built to be a flexible services platform, not necessarily web services. And all that web service technology was then put in front of it in order to have that standard access. Even when you have a proprietary protocol, you can also access the exact same services using all of these standard protocols. So that's really, I won't say an afterthought because we tried to do a very good job on it, and it works very well as a web services platform. But that's just one flavor of the technology that's underneath. So.
Oh, that explains it. That is more clear. Yes, certainly. You're absolutely right. And now that I think about it, where there are many other protocols that can be exposed low level as they were originally through some of those capabilities in ESP, but also they can be delivered encapsulated in HTTP or HTTPS. So that's that makes it very versatile. But then so. Can you tell us more about how ESP is so adaptive? What makes it so versatile? How did you architect it so that you can serve these protocols either native or encapsulated, and you can adapt and get new protocols supported almost on a monthly basis?
Yeah. So the first thing is that pretty much everything in ESP is a pluggable component with an abstract, well-defined interface. And it's all tied together at configuration time. All of those pluggable components are. So for instance, if you wanted to integrate with a particular security backend and you wanted to access via one of our proprietary protocols or as a web service, you tie all of those components together with their abstract interfaces at startup time, and then suddenly your service, which doesn't understand protocols at all, is speaking web service language or some proprietary protocol or some other format. So everything is just everything's pluggable. Everything has well-defined interfaces, and it's all tied together in that way. But then even beyond that, the services themselves, as you define a service, you use an interface definition language, we call ESDL. And beyond just describing the format of the message, it allows us to programmatically map it to all the different protocols. So for instance, if I'm speaking that proprietary protocol that I was talking about, or accessing the same service as a web service, or doing REST with URL-based processing, or other REST type calls, it's automatically mapped via that language to the service. But also beyond that, the interface definition protocol language allows you to version the interface. So one thing about our company is that things are constantly changing. You mentioned every month. It seems like more often than that to me. Just constantly, the same interfaces have to adapt and expand, and the same services need to support new functionality. But the versioning of this interface definition language allows us to have any given client lock into the version of the interface that it understands. So we don't have to stop progressing in order to prevent a client from being broken. If you look at how a lot of the web services were developed in the past with, the SOAP standards and things like that, they would basically say, if you make a change, you're publishing a new interface. But this technology allows us to continue to adapt and grow without breaking old clients, just by simply versioning new flavors of the existing interface.
Wow. That is abstraction, and I really like abstraction. Really, it's good to hide the details and just expose the high-level interface, right? So you can change things underneath the scenes, and and get new capabilities supported without necessarily breaking anyone else talking to you. That's very good. But you know what? And this brings us to the next question, which is abstraction has a price, right? You always pay some price in this extra high level interface. I don't know, being that performance or flexibility or any other. So, what were the biggest challenges that you faced when you designed ESP and implemented it, and what is this price for abstraction that you get to pay?
So yeah, the price for abstract. Well, we have a few different flavors of ESP in the way that it does the dynamic stuff. In the way that I was talking about, where everything's a pluggable component and tied together at configuration time, the ESDL definition of the interface actually generates code that handles all of the processing of the messages. So again, the service writer doesn't need to understand it, but it's also generated so that it's efficient, right? It's not walking through the definition of the interface at runtime and whatever. So that initial, think of it as the binary or static way of creating these interfaces was very efficient and generated before it was built. We moved away from that a little bit because of the fact that you then get stuck in this release cycle. So we do have new technologies that allow you to sort of publish the interface on the fly at runtime, and that does have a little bit of overhead of processing the interface as it goes. But it's all when it loads up, it's all pre-processed and turned into a pretty efficient set of internal objects that are meant to process the messages pretty quickly. So we definitely try to minimize the impact of that. Some of the other challenges early on was that if you think back to, this was 2001 when we started creating this, and SOAP was not yet a fully, it was not yet the de facto standard for web services. So when I say we started with some proprietary protocols, and then I started thinking about, okay, I want to standardize the interfaces of this component. What do I use? And SOAP and XML RPC, this other standard that nobody knows about anymore because it lost the battle. We're both battling it out for web service standards. So I had to sort of, I was implementing web services, abstracting making all this stuff pluggable, and at the same time trying to decide which avenue to go down in terms of all these standards that were being mapped out in the real world. So that was pretty challenging. And luckily, somehow I got it right and picked SOAP as the initial one. And then, but at the same time, I was mapping all the HTTP stuff, so you could directly go using a URL or a forum post. And that lent itself to the next stage, which of course was REST. So we were already pretty close to a RESTful. Even when we were doing SOAP, we were doing it in a RESTful way because we were mapping out all of that HTTP level protocol stuff. But yeah, I luckily picked SOAP as the standard to implement first, and that's what everybody adopted in the early days. So I got kind of lucky.
Wow, you know what? I don't know. Your reference to the RPC, HTTP protocols, the XML RPC, brought me some blast from the past on the early days of Ajax and interactive applications. And yes, you're right. XML RPC lost the battle, but it still sounds like a good memory from back in the day. But yeah, the amount of change that you have introduced, yet without touching the old functionality and still maintaining compatibility while supporting all of these completely different and new protocols that weren't even envisioned back in the day. That's just a lot of innovation. So that brings me to some other question, and this is, I think, the last question for today, which is you were recognized early this year because of your innovation and the amount of innovative things that you have done for HPCC Systems. And I want to ask you a little bit more in this area because if there is someone that has been doing innovation all along, and innovation that is sustainable over almost 2 decades, it's you. So what's the key to this type of innovation? What's the key to coming up with something new that is revolutionary, yet can be implemented and can be used in a production ready system. So how do you do it?
Yeah, I think for me the key, or one of the keys, I mean there's lots of keys to this, but one of the keys is instead of looking for a new solution, I'm looking for new ways of thinking about the problem, or looking at the problem, different angles. Or if somebody comes to me with a lot of times they come to you asking for a particular solution, and I start to ask them immediately, well, what is the problem you're trying to solve? Because I want to understand it and look at it from different angles, and maybe recognize patterns and other things other people are asking for. And so I really think it's that. It's sort of just taking a step back, ignoring the problem, ignoring the solution that people are proposing or that you might have recognized from outside, and thinking in multiple ways about the problem before you start to take action, looking at it from different angles.
Wow, that's and you know what? I agree 100%. That's the way to go. Unfortunately, we all have a mental structure that tends to go back to the if you're asking for this thing, then we will do that thing. But you're absolutely right. Looking at the problem and understanding what the problem is allows you to design the best solution without these constraints, artificial constraints on, someone asked me to implement this, so I implement this, and that's it. Yeah, you're absolutely right. So, Tony, thank you very much for doing this. This has been great. I really enjoyed this down the memory line as well, with the reference to XML-RPC and the early days of ESP, and learning that ESP wasn't even created for any of the things that it does today. It was created for something that was quite different, and yet it could do everything else that it's doing today without sacrificing backward compatibility and the original principles either. So it's great. Thank you very much.
Thank you, Flavio.
And I really enjoyed it. Thank you.
Thank you.